Hello everyone. In this video we will talk about the oscilloscope that we are going to use in the lab. This is again an oscilloscope by the company named Rigol. The model number is DS1054Z. This is a 4-channel oscilloscope. It has a bandwidth limit of 50 MHz and 1 gigasample per second data acquisition rate. The power cable is already connected in the back to a power line, and you can see that there are 1, 2, 3 and 4 channels. That means we can acquire data from 4 points on our circuit to these 4 channels. And there is a menu on the left. You can see there are soft keys. We can set different measurement parameters. There are also some buttons here. These are channel 1, channel 2, channel 3 and channel 4. When we press channel 1, then the channel 1 will be activated. When we press channel 2 will be activated, and so on. And this block is the vertical block, that is, it sets up the voltage scale of the oscilloscope. And this small block here is the horizontal block or time base. There is auto run. You can always acquire a single shot, and you can clear the data by pushing the clear button. And this is the trigger menu on the very right side that will be used to set the trigger channel and what type of trigger you want. And the very left corner bottom, you see the power button and USB port. So turn on the power supply. You see all the backlit is lighting up. It has many properties. We are going through some basic properties only in these videos. In the first, the LCD screen is lit up. Right now it is testing the oscilloscope self-test. Once the self-test is complete, as you can see, the self-test is complete. Channel 1 is lit up. There is no signal coming into channel 1 or channel 2 or channel 3 or channel 4, so we don't see any signal. This is the menu. There are 2 menus, one for the horizontal, one for the vertical, and it will give you different measures. If you want channel 2, we can click on channel 2. If you want to turn off channel 1, you can click on the channel 1, it is turned off. If you don't want anything, turn this all off. Let's keep the channel 1 on. In the very bottom left corner, it shows the channel 1 is lit up. It says there are 1 volts per division. This is the Y scale, Y axis. In the Y scale, you can see that 1, 2, 3, 4, 5, 6, 7, 8 blocks. So each block is a measure of 1 volt. If I want to change it, I can change it. This now, if you turn it clockwise, it reduces. It says 500 millivolts, that is half a volt. So this is half, 1, 1.5, 2. So 2 and 2, you can put a signal 4 volts peak to peak here, with centered at the center. If I want a signal that is 10 volts, that clearly will not fit into this screen, so we change. Right now it says counterclockwise. This is the voltage scale, that is Y scale, this button. 2 volts peak to peak, if you can change it. Now it will be 2, 4, 6, 8. So 8 volts below the center line, 8 volts above the center line, so 16 volts peak to peak. That should be good enough for measuring a 10 volt. And right now we also have something, this is called probe. Probe is set to 1x. So whatever the signal is coming, the measurement is 1-to-1 ratio. So if it's a 10 volts peak to peak coming signal, then we will see 10 volts measured. We can change the probe measure to 10x, 20x, let's see, 2x, 5x, up to 1000 times. So if there is a very small voltage, I can multiply it by 200 times to fit into the screen and see it nicely. And if the voltage is too high, we can change it to a smaller value to fit it under the screen nicely. In addition to that, currently it is coupling is AC setup. Right now there is no signal coming, we're not measuring anything. This is running automatically. When you want to acquire data, that will acquire data automatically. And in the very top, you'll see somewhere it's written H, and following that it's written 200 US. So U is standing for micro, so this is 200 microseconds. So each division is 200 microseconds on the x-axis. So there is 1, 2, 3, 4, 5, 6. Okay, so 12 blocks along the horizontal axis. So it will be 12 times 200, that's 2400 microseconds, that is 2.4 milliseconds. So the data you will see on the screen is of 2.4 milliseconds. If I want to see more data, more time, then I can change it. Now it is 500 microseconds. It may be very difficult to see on the screen, but I'm going leftward. Now it is 1 milliseconds. Now there is 12 milliseconds on the screen that you can see of any data. I can even make it more. It is now 5 milliseconds and so on. So depending on your signal frequency, you will have to change the time. Most of the time the auto will take care of it, but if you want to change it to your liking, then you have to change the time base. And this is the time. It says the menu. So it says YT. Right now we will not go into any other mode, and we are not going for delayed signal or pulse, so it will be turned off. And this is another important one. This is trigger menu. It says that right now triggering is edge type. The source is channel 1. So channel 1 triggers, then acquires the data. Channel 1 triggers and acquires the data. It is automatic. Channel 1 is triggering itself and acquiring the data. We can change it to channel 2. But now channel 2 is off, so it cannot do the channel 2. So if I turn it on and both channel 2, and then we go to menu again, the very right one, the trigger menu. Now if I want, I can set with the soft key channel 1 or channel 2 or the line, that is the AC. The line signal coming to the scope. So there is another button, it's called the measure button. We can measure different parameters, and there is also a button called cursor, so we can set cursors. You can turn it on. So it says, do you want manual or track or auto? I said, okay, I want manual cursor. It says what type of cursor you want. Right now this is vertical cursors, and if you click on select, there's the third soft key again. It says that I can do the horizontal cursors, and I can move the cursor, you can see that, to measure a signal. this is for the first video. In the next video we will connect it to a signal from the function generator that is right now just below the oscilloscope. So this is kind of a not very good way to put a function generator and an oscilloscope, because there is a chance that the oscilloscope may topple. I am very carefully doing it because of the purpose of completing the video, so that I can have both on the same screen without changing the focus and any other parameter. So in the next video I'll show you how to acquire the signals, how to see the signals on the screen.